Okay, so I've been asked to give a little bit of help on the question 3.65, which is the Brady's Leap question. Starts off with a visual here of Brady jumping off a cliff to land on the other side, and we've been told that the height of this cliff is given as h, and the length across the river is L. And so you have this little setup on your Mastering Physics assignment, and it says the question is to representing the horizontal distance as L and the drop height as h, derive an expression for the minimum speed v he would need to make this leap if he ran straight off the cliff. So in the end, what we're trying to get is the velocity of Brady, which we know just the basic velocity, since the velocity in the x direction doesn't change, is distance, which in this case is L, right? The distance we're trying to get across this river is L divided by the time, which we don't know. As with all the other problems, we've needed to solve for time in the y dimension. So we will start in the y dimension, and then we'll come back, we'll solve for t, and we're going to plug that back into this equation right here. So if we're only thinking in the y dimension, right, basically he's falling some height right here. And so what do we know about this? We know our initial velocity in the y is 0 meters per second. We know the acceleration in the y is little g, the acceleration due to gravity. That's 9.81, but I don't think they want the numbers here, just the variables. And we know the displacement in the y direction is h. So given these things right here, which kinematic equation are we going to use, and we sort of go to the same one all the time for dimensional, or for these projectile problems like this, and that is the one that's x equals v initial t plus 1/2 a t squared. And so then now we can just go and we can plug these values in to our equation down here. And so x is h. V initial, we know that since he's running off, its initial y velocity is 0, because he's basically like if you dropped a ping pong ball here. So the initial y is 0, so all this is going to cancel out, plus 1/2. Our acceleration is little g, gravity, acceleration due to gravity, t squared. So that, just reorganizing this, 2h equals g t squared, and so t equals 2h divided by g square root of all that stuff. Now we're going to take this, we're going to plug it in for t up here, so in the end, therefore, we get velocity of Brady equals L over the square root of 2h over g. We can simplify that a little bit more. The velocity that Brady needs is L times the square root of g over 2h. And I believe that that's the type of derivation that they want. This is a typical question for AP style. And so what we're doing is we're basically just not even plugging any numbers in. We're saying, all right, what is the velocity that's needed in the x direction? And so we've solved it for these variables. Now, as you can see in the next couple of parts, they're going to ask you just to go and plug numbers in for these two variables, these two unknowns. So we've set ourselves up to be a little bit more efficient as we move on. Hopefully that helps. Have fun.